Hello. So now we are going to talk about how we can use simulation to find out probability. We know probability is long-run frequency. So how we can verify this or find out? So suppose you flip two coins in one experiment. X is the number of heads you find out. For example, if two first one head on, second one tail on, that's one head. If first tail, second coin also tail, that's 0 head. So the possible value for this number of heads could be 0. So 2 times you have tail tail, or could be 1 if you have head tail or tail head. Or 2 times you both have head head. So now we need to use simulation. We try to do experiment 1,000 times and then find out how frequently you get 0 head, how frequently you have 1 or 2. So how we can do this? So first we need to generate a random number, okay? Just a random number. We use this formula. Okay. So this generates a random number between 0 and 1. And then we need to test. Suppose this is the first time you flip the coin. You test is tail or head. Okay. So we use an if function. If this value, we know this 50% every time you try, right? The probability. So if this number less than 0.5, I think that's a head. Otherwise, that's a tail. Okay. So this time, first try head. And then we need to do our second flip the second coin. Okay. Random number. So still this will generate a random number. So this random number are independent from this column. Okay, so it's like you first flip the coin and you second time try. These two events are totally independent. So next, we need to find out, based on the random number, if this value is less than 0.5, that's a head, otherwise tail. So we simulate you flip the second coin. So this time, head, tail. So we just copy, just to put these results together, equal to tail. So we have here is the first one. Here is the second coin. So this experiment shows you flip 2 coins, you got head, head. So number of head, we use a count if this is the range, okay? We just count these 2 and then how many are head. So tail, head, so there is only 1 head. So we have, this is what we need to record, number of heads of each trial or each experiment. Next, we need to do this 1,000 times. So yeah, you can either drag, see, or you copy paste to next 1,000. Yeah. So since my first 9, so I should be here 1,001. Okay, so total I tried 1,000 times. So now we work on this. We use x to indicate the number of heads. So we can see x equal to, so x, since every time before you try these two coins, you don't know value of x. So x we call a random variable, because you don't know the outcome of x. You only know this is, you list all the possible outcomes. It's like sample space. Okay, so frequency, we use how many out of this 1,000 have had 0. Okay, the number of head is 0. You just count if the range is here. We use Shift Control down key in, move up a little bit. Okay, and then I like to put $sign. So the $sign indicate this range. When you copy this formula, the range wouldn't change. It's like a fixed value here. I count if this equal to 0. Okay, so how many of them equal to 0? So 272 out of 1,000. So I also can just copy, Control C, and paste. So this time I paste the formula. See, I pasted, I have $sign, so the cell still fixed. So otherwise, this number 2 will change to number 3. Okay, but here I just change this to 1, and this change to 2. So I know the frequency. So relative frequency equal to the frequency out of total number. So we tried 1,000 times. This one I also can just drag, copy the formula. So this is frequency over 1,000. You also can test relative frequency that's add together. That should be equal to 1. You look at here, have a sum equal to 1. Okay. So yeah, I need to reformat. I like to put the, see the borders on the table, outside of the table. Now we look at the table. It shows the relative frequency when you observe number of heads when you flip 2 coins. So here, number of heads, we use X to indicate. X, every experiment, the outcome is keep changing. Could you observe 0 head, or 1 or 2? So X is a, we call random variable. So this random variable have the probability distribution, okay? So what does this mean? We can theoretically find out the probability x equal to 0, to 1, or to 2. So how can we find out? So if we flip 2 coins, see outcome, okay? So we put here, see outcome. Flip 2 coin could be head, right? Or could be first head and then tail. Or could be tail head, could be tail. So if flip 2 coins, the outcomes is only these 4, right? And also it's equally likely to happen. So if you observe number of head, this x value, okay? It could be, see for this outcome we know this is 1 out of 4, right? The chances you observe, because it's equally likely to happen. This is equal to 1 out of 4. So this is the same. 1 out of 4 equal to 1 out of 4. You add all this together, That's the whole sample space. That's 4 out of 4. You list all the possible outcomes when you flip 2 coins. Now you see x have the value 0. So what's the probability you observe 0 head? That's the only this one, right? No head. So the probability equal to 1 out of 4. Equal to 1, these two, right, both have head first or head second. So that's 1/4, a quarter plus a quarter, that's a half. 1 out of 2. And you observe 2 heads, that's the only, you have head and then another head on. So that's equal to 1/4. You add these together, that's 1. Okay, so this is the probability of x. When x, you see, list different outcomes associated with the probability. So this table. So you look at this one. This is the theoretical calculation. And this one comes from our simulation, simulated 1,000 times you do this experiment. So this is quite close, right? So 0.25, it should be 0.25. So this is 0.5, 0.502 is quite close. So we use the simulation, we can find out, so long run relative frequency, that's the probability. Okay, so we verify this one. Another thing in this lab, we need to understand a little bit more on this random variable. So what's the average value? So we know it could be 0, 1, 2. In the long run, what's the average of this x? Okay. So how we find out? I need to rewrite it, just equal to 1 over. So we have this probability. So we can calculate on average what's the value of x. So we call this mean of x, or you can average of x. Okay, that's equal to the value, the outcome multiply its probability. Okay, plus this value multiply the probability plus the value, outcome value multiply probability. That's equal to 1. Okay. So there is another easiest function in Excel. We just use the sum product. Two columns multiply and then add together. So that's the same thing. So this is we calculate theoretically from this probability table. Next, so from the experiment, we can take the average of your x value, number of head, we take the average. So that's close to 1. So we verified the theoretical one and the long run average, that's the same. So this long run average has the name we call mean of x, or we call expected value of x. Okay. So another thing is very important when we learned how to describe data. We not only use mean, right, the average, which indicate where is the center of the data. We like to know how it is spread out. So for this random number x, it could be 0, 1, or 2. So how it is spread out? What's the shape of that distribution? So for this one, we also can calculate standard deviation. Okay? So we also can calculate the standard deviation, to long run deviation from the mean. Standard deviation, there is a formula, standard deviation, sample standard deviation. So number of head every time we tried 1,000 times. So standard deviation is this one. Okay. So theoretically, how this x value like spread out. So we look at their distribution. So standard deviation we calculate this way, equal to, so first we need to add each value x, how far away from this one, right, from mean, and then we square, and we multiply how often this happened. That's the probability. Okay, plus, so 1x equal to 1. So how far away from this center, from mean, okay, the distance or the difference from the mean, and squared, and multiply how often this happened or what's the probability. And plus another possible outcomes, how far away from center, and we squared, and then multiply the probability. And then you need to take square root. So SQRT, that's the function to take square root. So theoretically, x, the standard deviation, is this value. And what we observed is quite close. So every time if I to do some operation on Excel, these two values will change because every time you do something with Excel, this random number will change. Okay, so this is end of part 1. So we learned relative frequency, how we can use experiment, like simulate the experiment in Excel to verify the long run relative frequency is the probability.